and welcome. In this introductory video, I'm going to introduce you to my favorite operating system, which is, you guessed it, it's Linux. I'm going to talk about the what is Linux, its distributions, and the file system in Linux. And moreover, I will walk you through the basic commands that you may need as a beginner of the Linux operating system. I'm excited. What about you? So let's begin. Linux is a free Unix type operating system originally created by Linus Torvalds. It's originated in 1991 as a personal project of Linus Torvalds, who is a Finnish graduate student from the University of Helsinki. The kernel version 1 was released in 1994, and today the most recent stable version is 4.6.5. Linux is developed under the general public license, and the source code for Linux is freely available to everyone. Linux has many distributions. Most common ones are Mandrake, Red Hat, CentOS, SUSE, Debian, and Ubuntu, and many others. Red Hat Enterprise is an enterprise targeted operating system. It's based on an open source technology, but is available at cost with 1 year Red Hat network subscription for latest updates and upgrade and contact support. Linux file system is derived from the Unix and looks like an inverted 3 structure, as you can see on the screen right here. It's like flip 3. You start with the root directory denoted by the slash. Denoted by the slash like this. This is the root directory, or the top directory of all directories. At the top, and then you work down through the subdirectories underneath it. You specify file or directory by its path name, either the full or absolute path name, or the one relative to a location. For the full path name with the root denoted by the / symbol, and follows the branches of the file system, each separated by a / until you reach the desired file. As an example, if you want to go to folder 2, which exists under home update folder 1, you could simply type cd, which is the command that that will take you to the desired folder. In our case, folder 2. So let's log into the machine and clear the window. Okay, let's print in media right now, so let's go back. So let's do pwd first. This command prints the working directory, pwd. So I'm in the root directory. If I will issue the ls command, I'm going to see all the directories under the root directory, as we talked about here and as demonstrated in this diagram. So I want to go to folder 2, as I said. So I'm going to do home update and folder 1, and then folder 2. So if I will do pwd, print the working current directory, I'm I'm in home, update, folder 1 and folder 2 in a relative fashion. If I want to go back to home or update or maybe the root directory, what I need to do is cd. It will take me back, right? In Linux, we have two special directories denoted by the symbols either the dot, just one dot, okay, or two dots like this. So if you will do cd followed by one dot, you will be just in the current directory. One dot means the current directory, and two dots, it will take you to the parent directory, as we will demonstrate here. So let's print the working directory. Well, in the root directory. This is the directory of the root user or the super user. So I'm going to go back to the root directory or the top directory, do an ls, and I'm right here. So let's do cd to home and update. Okay, pwd, I'm in home update. So if I want to go to the parent directory, who is home, I will do 2 points, right? Or 2 dots. It will take me to the parent directory. But if I will issue just the 1 point, it will take me nowhere because that's the current directory. Okay, so let's go back to our root directory. Here we go. If we'll go to list and minus LA, which shows also the hidden files, because Linux hides some directories and files. In the top here, you can see the dot, which means the current directory, and the two dots, which means the parent directory, and along with the other files. I'm going to list those right now. So let's explain all those directories and what each directory is for, right? So the root directory, okay, /root, it's the directory for the super user, right? And the slash here, the top directory, I mean the directory that holds all those directories, the root of all directories on the system, and other directories and subdirectories of this directory, either directly or through other subdirectories. We have also the boot directory. The boot directory have a bootloader and other configuration files that tells the system how to boot. We have also the etc. The etc. Directory contains system configuration files, startup files, etc. Lib 64, as you may notice, we have lib 64 and lib 32, which means lib and lib. Lib is essential system libraries used by tools in the bin directory. Okay, and here we have the important file, which is .proc. .proc contains all the files that give information about the current system processes. Let's check the proc directory, ls. Here you can see that we have running processes along with the some information about the hardware. For example, if I will issue the command more CPU info. Okay, it will give me the information about my CPU, which is Intel Arc-Core TM-i5 CPU, and other information also. If I will ls again, I can see that we have mem info as well. So if I will issue more mem info, I will check, or I will see all the information about the memory, total memory, the free memory, available memory, and so on. So that's the proc file system. Okay, let's go back to our directories. We have also the SRV. The SRV stands for site-specific data reserved by this system, such as data and scripts for web servers and data for FTP servers. Okay, and the temp directory is a temporary directory. The var, actually the var stands for variable files, holds the variable files, whose content is expected to continually change during normal operation of the system, such as the logs, because the logs are always growing and growing. It will cd to var, for example, some service, let's say Apache, okay, var log and Apache 2, and okay, we can see that the error logs related to Apache 2. Since we didn't run Apache 2, we can't see any errors related to Apache. That's why the cat command didn't give us anything. Let's go back, and here we go. We talked about the var, so the bin directory have the essential tools and other programs or binaries. The dev directory, which is an important file, have the files representing the system various hardware devices. For example, if you plug SDA device, I mean hot plugged USB, immediately it will shows in the /dev. If we'll go to /dev dev directory, we can see that we have the SDA 0. SDA, and SDA is the physical hard disk, and those are the partitions for the same hard disk. And we have other devices like CD-ROM, we have the CPU, we have the DVD, and so on. So this dev file, whenever a device is plugged to the system, file in dev is created for that device. And also we have the home directory. The home directory have all the system users directories. If I will go and create, for example, a new user, this new user directory automatically is created for this new user in the home directory. We can do that. Let's add a user called Linus, for example. Okay, and Linus password. Okay, try again. Here we go, here we go, here we go, and it will ask me the basic information. Yes, and here we go. We'll cd to home, we'll check, and we have the Linux directory created for the new user. So /home is the directory that holds all the system users. The lib directory have all the libraries and device drivers as well. The media directory have it's like mount points for removable media such as CD-ROMs. If you plug a USB CD-ROM, it will show immediately here. In fact, let's go there and check what's in there, right? So we can see that we have CD-ROM and CD-ROM 0, right? Also, I want to talk about the opt. The opt stands for optional, and it have the contains the third-party application software. The root, I think I talked about that. This is the super user's home directory, whose username is root, right? So don't confuse that with the root directory with this slash right here. This is the root directory, the top directory of the three, and this is the home directory of the root. Okay, all data of the superuser resides in the root directory. We have also the SBIN. The SBIN is essential system administrator tools or system binaries. The sys, this is important file. Here we are going to talk about this later also. But for now, this holds information about all the hardware. And you can think of this sys as the database information of the hardware. Okay. So I think we cover everything in this USR. Yeah, USR stands for Unix System Resources, and it have the subdirectories with files related to user tools and application. Okay. So the sys or sysfs, okay, this file is a virtual file, means that when a computer boots, it runs into the RAM, and it's like the database of the hardware, and also it exports the information about the hardware to the system. Also, I want to talk about some daemons that run on Linux, which are important, and you should know them. We have the sysfs, we talked about that. We have the HAL, which stands for the Hardware Abstraction Layer daemon. This daemon starts up with the computer. When the computer boots, it runs at startup, and it tells the application about the hardware. Whenever it detects a device, it tells the application about it, and also it abstracts the differences in hardware from the most OS kernel. For instance, if you plugged an Ethernet card to the system, if you plugged an Ethernet card to the system, it will take a device name as ETH0. If you plug another Ethernet card, it will take a name of Ethernet2, and so on. Although the device real name is Realtek or Atheros or whatever, other vendor, right? So it abstracts the hardware from the Linux kernel. We have also the desktop bus or D-bus, which allows the communication between the hardware and software to occur, and also tells the processes about plugged devices. Whenever a device is plugged, The dbus is send the message and tells the process that this device is plugged. Did you want to do something with it or so? So dudev also, it's a daemon. A daemon runs in the background, and the udev, but this is responsible for creating files in the dev directory that we talked about earlier, right here for every device. And also listens for U events from the kernel. And really what's happened and when you plug a device, the udev pick up the message and follow the rules that exist in the ITSE. Yeah, right here ITSE slash udev and slash rules, I believe, rules dot d, rules dash d. Anyway, you get the idea, right? So yeah, after that I'm going to talk about the Linux structure. Linux structure, it looks something like this. We have programs. The programs are application software, and we have the kernel, which is the core of the OS. Okay, and we have, of course, every computer has hardware devices plugged into most of the computers, and most of the devices are detected in the initial startup by the BIOS and are processed by the post, right? The or POS T. Okay. And when you plug a device, let's say we plugged a USB device here, right? USB device right here. What happened is the udev daemon picks up the message. Okay, udev picks up the message udev, right? So udev here, okay, picks up the message from the kernel, and then follow the rules that exist in the ITSE. Okay, ITSE udev and then rules.d. Okay, whenever the rules that are written in the rules.d, it will tell the device what to do. Then the device starts up. Okay, device up, and then the file in dev is created. Okay, file in dev is created by udev. Okay, if we plugged USB dev slash USB, for example, right? And then the device initialized, and it tells the process that this device is new and is ready for operation. So to wrap things up, we talked about the history of Linux, what is Linux, and we talked about Linux file system and the hierarchical design, if we could say, of the file system, like /home, /bin, /lib, /dev, proc, root, var, and so on. We issued a couple of commands, basic commands like pwd, cd, ls, more, and cat. We also learned about the CSFS, the HAL, the hardware abstraction layer, and the dbus, desktop bus, and the udev, and what udev do its responsibility, as we mentioned, like it creates the dev file whenever a hot pluggable device is added to the computer. And finally, we talked about the Linux structure and how Linux knows about new devices. I hope this has been informative for you, and I'd like to thank you for viewing.